Hey there, it's Jason from Codemanship with another video diary entry on a sunny Sunday morning. Cold but sunny. If you're enjoying these videos or finding them useful or amusing, please like and subscribe and ring the bell for notifications for new content. So I work with a lot of teams who have gotten into this bad habit really of jumping straight into code without really giving it any thought as to what it is they're going to be doing, what their design is going to be. So I wanted to sort of cover in this diary entry this question of what do we do before we write code. So I'll talk about the kinds of things that I would do before I start writing production code. And I'm going to use the Guitar Shack example. So this is an exercise that I use in training and coaching where pairs or teams are challenged to come up with a minimal design, if you like, a minimum viable product. The simplest system design that they believe would solve a business problem for a fictitious musical instrument shop called Jason's Guitar Shack. The problem they're trying to solve, don't worry too much about it, is the shack keeps running out of stock and therefore losing sales, basically, because when we order more stock, there's a manufacturer's lead time for every product, during which time we've got none to sell. So we're losing sales and we're losing customers. So they're challenged to come up with a simple system design, working with their customer, that's me, hello, working with their customer that they believe could solve or mitigate this problem. In other words, that would reduce the number of lost sales. Okay, so the system design they usually go for, the simplest one they can think of, is something that intercepts sales events from our point of sale system. This is the till, basically, in the shop. Intercepts sales events. So every time we make a sale, we get a sequence of events for every product. We get a notification saying which product ID we sold and the quantity, the sale quantity that we sold. There are back-end systems that already exist at the shop house. There's a shop that has the entire sales history for every product. And that's the data that we're looking at now in the spreadsheet. And there's also a warehouse system that stores information about product descriptions and so on and so forth, but also, very importantly, how many we've currently got in stock in the warehouse. This is before that the sale has been fulfilled. And the manufacturer's delivery lead time in days. How long would we have to wait for more? And so we sort of work with them. And typically at this point, if you're into test-driven development or behavior-driven development or acceptance test-driven development or customer test-driven development, or more generally specification by example, we would work with our customer for this. In this case, they come up with a design that only has the one feature, really. So for this feature, we break it down into scenarios. We can think of two here, for example. One where a product needs reordering, so we send an alert to the manager, say, please order more of this particular product. And then we come up, very importantly, with an example, which is just another word for test. So for product 811, that's the Epiphone Les Paul Classic, a big seller for us. We've sold one of them. We've got 25 in stock at the moment, which means after we've processed this sale, we're only going to have 24. The restock level for that product is 24. In other words, we would expect to sell 24 more of them. If we ordered today, we would need 24 in stock today so that we don't run out before we get more. And finally, that's the exact contents of the message that we should be sending. That's the alert we should be sending to the store manager. We've also got other scenarios we need to think about, like what happens if it doesn't need reordering and so on and so forth. Okay, so this is all quite familiar to people who are used to specification by example and test-driven development. So there's probably no new information here. But what a lot of the teams do, the ones that do sort of work in this way, is they take these tests and then they sit down and they start writing code. But it ain't that simple. Now, at this point in the Guitar Shack exercise, we're right at the beginning. So we're thinking about system design kind of from scratch. So it is useful at this point, rather than just jumping straight in and writing tests, for example, to actually go away and have a think about the internal design, the logical high-level design that we think would work in this particular scenario. And typically the way I do it is, first of all, to sort of break it down into scenarios. So if we take a look at this little PowerPoint presentation, I've sort of broken it down for this particular feature. Something is responsible for deciding whether or not to send that alert in the first place. Something is responsible for figuring out what that restock level is. In other words, how many would we expect to sell before we can get more? Something has to send the alert, and we don't know how it's going to do it yet for that particular product. Something has to fetch the product information from the warehouse system so we know how much stock we've got and what that lead time is. And something has to fetch the total number of sales for the last 30 days. So we're basing restock level on average daily sales over the previous 30 days. And therefore something has to go to the sales history and find that out for that particular product. So there are 5 responsibilities, and good software design, good modular software design doesn't start with objects or modules. It starts with work, responsibilities, what needs to be done. So 5 responsibilities, and implied in this also are interactions or collaborations. That thing that makes the decision whether or not to send the alert has to collaborate with the thing that calculates the restock level. And so if we break this down, we can kind of come up with a high-level design in terms of roles. What are the things, what are the modules, if you like, or the classes, their responsibilities, what are they responsible for doing, and their collaborations, who are they interacting with in order to coordinate their work. So we can go on and maybe do something like a UML sequence diagram. I don't know when you last saw one of these. We can go to the whiteboard and draw a little sequence diagram and so say, look, this is the high-level design that we think will fulfill this particular scenario, that will pass this customer's test. So we have the stock monitor that intercepts the sale event. It's got a handle sale event handler there. And it needs to talk to the warehouse to get the product information, the stock and the lead time, etc. And it also needs to talk to the thing that calculates the restock level. The thing that calculates the restock level needs to talk to the sales history, which fetches the total sales. And this, the sequence diagram is wrong because it's not that one that does it, it's that one. So I'm just fixing it on the fly there, just in case you thought I was perfect. And our stock monitor needs to collaborate with the restock alert, the thing that sends the alert. Okay, right, so let me just save that. No, maybe not save it now. Okay, so there's a little thinking about the high-level design. So if we were to sit down and start writing, let me tidy that up a little. If we were to sit down and start writing tests, if we were working from the outside in, we would start here with a test for that. And if we were working outside in the style that's described very eloquently in the book, Growing Object-Oriented Software Guided by Tests, when we're writing the unit test for the stock monitor for handling sales, we would probably stub the warehouse, so we would just define an interface for that for now, and we wouldn't worry about how it's actually getting the information from the warehouse system. We would stub the restock alert, and we would stub the restock level. In other words, all the things that Stock Monitor collaborates with, we would fake it until we make it, so that we can test drive making the decision, basically, as to whether or not to send the alert. And then we would work our way down the call stack. So we've got a much better idea of what our call stack looks like. It's not super detailed. There's still many more details to be filled in, much code to be written, but it gives us a high-level steer, a high-level map, if you like. Remember, the map isn't the terrain, but it is useful to have a high-level map before you begin, particularly when you're just starting out on a system design. So this is something that I would typically do, and I encourage teams to do. Get around a whiteboard. Don't jump straight in. Don't design the whole system. Just worry about, well, for this scenario, for this particular test case, this is the design we think would work for us. So get a sort of a high-level steer on that. Okay, now we've got a design for that test case. You think, oh, he's going to start writing code now. Not necessarily. There is going to be code. But there's a chapter in Steve Freeman and Nat Price's book, Growing Object-Oriented Software Guided by Tests, called The Walking Skeleton. And I think this is a really good idea. Now, the whole point of software development, and people often will use the word software delivery instead of software development, is that there is that delivery side of it. In other words, we need to think about how we're going to get this from our desktops, if we're working, I'm going to be working in .NET Core today, from Rider on my desktop, eventually into some kind of production environment. So we need, first of all, to think about technical architecture. Now, with technical architecture, usually what we're talking about is constraints. Excuse me. What is constraining us here? And there are actually some technical constraints. Constraint number one is the point of sale system that sends out these sales notifications, these sales events, can communicate via HTTP to other systems. So it's going to be some kind of web-based service. Basically, it's going to be a web service or a microservice or a Lambda on Amazon Web Services or a function on Azure or something like that. So probably some kind of microservice. So it's going to be web-based. If I'm a .NET Core developer, then it's probably going to be an ASP.NET Core Web API of some kind. So we've already made a decision based on the constraints that I am a .NET Core developer. I'm not, by the way, but I will be today for you. That I'm a .NET Core developer, and our input is going to come over the web. So that kind of constrains us. The other constraint we have is concerning the actual alert itself. How are we going to send that alert? And that constraint is that the store manager, Jeff, doesn't use computers. I mean, he will use things with computers in them, like sales tills and kettles and things like that. But he doesn't actually use computers. And that includes smartphones. So this isn't going to be some kind of app with notifications, because he doesn't own a smartphone and does not want to own a smartphone. Remember, this is a guitar shop. So we're probably going to have to send him text messages. So we're kind of thinking in that sense, well, our technical architecture is constrained by the fact that we are .NET Core developers. It's constrained by the fact that our input is going to be some kind of web request. And it's constrained by the fact that the store manager does not use computers, but he does own a mobile phone. So we can send him texts to remind him to order products. And that's how he would prefer to do it. So that's what we've decided. It's going to be ASP.NET Core. So that gives us a starting point. We think about that technical architecture. And then what we do, rather than just jumping in and start writing our unit tests for that stock monitor, we create this walking skeleton, essentially. Now, in actual fact, Ryder has generated one for me. When I created this new web API, this ASP.NET Core Web API, it actually generated a skeleton for me with this weather forecast web service. So that gives me something that I could build and test and deploy, even though it doesn't do any of the things we want it to do yet. It is the technical architecture, pretty much. It's an ASP.NET Core application. Now, I've split it out a little bit, so I've actually kind of gone ahead there and decided I want all my core logic in just a plain old DLL. So there's a .NET Core DLL there where all the internal logic will go. And I'm just a great believer that your user interface layers should be as thin as possible. They should do as little as possible. Okay, so at the moment I've got no internal logic. I've got a web service that pretends to tell you what the weather forecast is. But that does mean that I can build, test, and deploy this. So the next thing I do, of course, is I get it into version control. I create a Git repo. I commit this walking skeleton, and I push it to a GitHub repository. But we're still not, and for most developers, that's kind of where they think that the delivery pipeline ends, because they don't normally see the rest of it. But I think as developers, we do need to be aware, at the very least, aware of the entire delivery pipeline, if not hands-on involved with it. That's kind of what DevOps means, by the way. So when you say you're a DevOps developer, this is the stuff we're actually talking about. So I want the complete pipeline. So I want to think about, where am I going to deploy this? Now, it's .NET Core, so it would make sense out of the box to go for the easiest option. And it just so happens that I have a Microsoft Azure account. So I could deploy this as a web service on Microsoft Azure, probably pretty straightforwardly, really, because it is a very vanilla ASP.NET Core project, and Azure will do that very nicely out of the box. I haven't gone for any particularly fancy options here. So what I've done is I've set up a GitHub action that will build and test my application, my web service, and the core logic. And if that build succeeds, then it will automatically deploy it to Azure, so we can actually go look at it in production. So let's do this now. Let's make a little change to it first. Have I made any changes to it? I think I just did a hard reset, because this is take 3 of this video. So let's go take a look. I've got a test in here, but it's just a dummy test. So I just want to know that tests are being run. So I need one test so that I can check in my build that the tests are actually being run. And so I can also check that it's only being deployed if the tests pass. So here's my dummy test. Let's make a little change to it. Let's just add a line there. So we've got some dirty code there. Okay, and let's first of all make sure Very good habit to get into before you even think about committing. Run your tests. Make sure that the thing does work. We should any moment now get passing test. Good, lovely. Let's commit that. We're happy. So never commit unless your tests are all passing. And so I'm just demonstrating the delivery pipeline. So this process is described in a lot more detail in the continuous delivery book by Jez Humble and Dave Farley, which I highly recommend buying a copy of. I think it's one of those books like the Refactoring book and Test-Driven Development by Example, Growing Object-Oriented Software by Test. It's a book I highly recommend that developers actually buy, because you've got to spend a lot of time with it. Okay, so let's commit that and push. When I push this is going to trigger a GitHub action. So let's go take a look. Always keep one eye on the build. Let's go take a look. So that's the workflow that I'm actually running there. Let's go look and see what it's doing. So it's queued up a build, but let's take a look inside this workflow while it's working. Okay, so there are two jobs in this build, and it's triggered whenever someone pushes to the main branch. So I advocate trunk-based development, as they call it, which means we're all pushing our changes to the trunk branch, and the implication there is we must be damn sure that what we're pushing actually works, which means everything we commit must pass the tests. I've talked about that in a previous video. Okay, so we set up .NET Core, we run our build, we run our tests, and we publish and package it, ready to be deployed. And then if that all succeeds, our next job, we actually deploy it automatically to Microsoft Azure. So we're actually going live to production. Let's go back and check and see how our build is actually doing. Okay, so it's taking a long time because it's doing a lot more than just compiling it and running it in the tests. Excuse me. Now, this workflow, by the way, is not compulsory. There will be many different kinds of technical architectures and many different kinds of business or customer situations where it would not be advisable to deploy everything that's successfully built and passes the tests. For example, if you're deploying things to the Apple App Store, for example, then there's a whole process you have to go through, and it's just not feasible. You can't do that 20 times a day. So in those cases, you probably have continuous deployment to some kind of customer test environment, some kind of maybe a staging environment instead, and then your actual deployments to the App Store would be on a regular basis, hopefully, but maybe once a month or once a week or something like that, where you feel like you've built enough value, you've added enough value to the product to actually go through all the pain of putting it in the App Store. Okay, so it's taken a little while. It's been a couple of minutes. It's typically around 2.5 minutes at the moment. It was significantly quicker yesterday, but remember we are on the cloud here, and also GitHub seems to be a bit under the weather at the moment. It went down last night for a couple of hours, so maybe that's connected to it as well. There, so that's the whole pipeline done. We can just check what it did. It built it, and then because the build succeeded, it deployed it, told me where it's deployed to, which is a useful thing to know. And if we just check in the build, so always check when you're setting up your builds that the whole process is doing, and in particular that the tests are being run. And that's why you want that kind of dummy test in there, basically, just to make sure, okay, tests are being discovered and they're being run. Okay. It might be worth when you get started to actually deliberately make push a failing test, also to make sure that it doesn't try to deploy it unless the tests are all passing. Okay, so that's a complete deploy, and I can go look now at my web service. This is the weather forecast web service that's being deployed. There you go, and there's my randomly generated sort of pretend forecast for the next 5 days. So we are building and testing and deploying our ASP.NET Core website. And that is the point at which, when we've got that conveyor belt, that delivery pipeline up and running, which means when we start adding value to our product, that value can be immediately made available to the customer, either for testing or for actual use. then we can begin thinking about, let's write some real unit tests. So I'm just going to end this by saying, well, this is the point at which we start writing the real code. This is a dummy test. We don't want this anymore. So let's get rid of our dummy test. Let's write a new. I'm going to keep the web service, by the way, because I just still want to know that it's being deployed until we're ready to put the web service on the front of our core logic. Okay, so this is for our stock monitor. So this is the entry point to our logic. It's not the entry point to our system. It's not a web service. It's not an API. Notice I am not writing tests. When people say outside in, often people misunderstand, say, oh, you're writing tests for the API. No, I'm writing tests for the logical API. That is the entry point to the logic. And these are my stock monitor tests. So for this handle sale event. Okay. And so I'm using xunit.net in this particular example. Okay. And public void product sold. So this is the point at which I'm kind of copying and pasting or just regurgitating what's in the spreadsheet. So if you watch my videos on CodeCraft for .NET or any of the other languages I've done them for, when we talk about specification by example, how that leads into a unit test-driven development process, we're using our customers' tests. These are meaningful tests. These are tests that mean something to the customer. And then that means essentially we're taking them directly from that spreadsheet. Product sold, the alert is sent. Okay, and let's start at the end. Now, what is the assertion here? The assertion here, we go back to our spreadsheet, is that this alert is sent with this message. Now, we're sending something. It's an outgoing piece of information. So there's no easy way. We can't sort of expose that in any way except by testing it using a mock alert. So I'm going to use mock essentially to verify that the send method, the one that we sort of modeled in our little sequence diagram there, that send method is actually called with that message. It should really be the message. Oh, yeah, I'm struggling with this. Like that. So, back, I don't want to do a save quite yet. So that's what we're actually going to be verifying, that interaction actually takes place. Okay, so let's imagine we have a mock alert and we want to verify that alert send is actually called. And I'm going to copy and paste the exact message from the spreadsheet. So it's exactly what we agreed with our customer. Okay. Okay, and now we can work backwards from there. So let's create a mock alert. We're going to use mock to do this. And let's work backwards from here. First of all, let's import that. So we're going to define alert, but we're going to define it. It would be really nice, by the way, Rider, to have the option to create this in a new file, save a bit of refactoring later. So we want this to be an interface. And it needs that send method. So in this test, we're kind of we're designing the interface, so even though we've already kind of designed it, but now we're getting to the real detail of exactly what is it going to be. So let's create that method and let's give that parameter the name that we had in our spreadsheet and in our little sequence diagram there. Okay, so that's our alert, but what are we actually testing? We're testing this stock monitor. So let's create this class here. This is the thing we're actually testing. Okay, and our stock monitor needs to be able to talk to the alert. So let's inject that in as the first dependency. So we're going to construct the call stack from the outside. Okay. And we don't want that to be a mock alert. We want that to be an alert, which means I've forgotten. I keep forgetting to do this. It's been a while since I've done any C#. Okay, there we go. So that's the alert being passed in. We don't need to do any more for that yet. Okay, and the event that we're handling, we called it handle sale, or you can call it on sale or something like that, but in our little design we called it handle sale, and we said that the product ID was 811 and the quantity was 1. You can copy and paste that if you like from the spreadsheet. So I'm kind of at a much lower level reproducing not just the customer's test, but reproducing that sequence diagram, but just the first level of it, which is the stock monitor and its dependencies. And I'm modeling its dependencies as interfaces. Okay, and we probably need to give those meaningful names, and we called that the sale quantity. Okay, in our spreadsheet. So we're using the customer's language wherever possible. Okay, now we're still missing some test information here. So as well as our mock alert, we also need something that provides product information, so we can, for example, find out the stock level of that product. So let's imagine, first of all, that we have a product, and we'll call that product 811 and give it stock. In our spreadsheet we said it was 25, that's the current stock level. Now of course if you're using spec, flow or cucumber, well, the tool will do all this for you, but I kind of like to type the code. I'm a big believer the code needs to go through your head, through your brain and through your fingers. Okay, so let's create that class product, and we need an ID and we need a stock level, okay, for now. Okay, and we need something, so we can't just pass the product in, we have to fetch the product from the warehouse. So we need an interface. So let's create this interface warehouse. So this is our second dependency for stock monitor. And okay, let's make that an interface. And we're going to stub it. So let's create a stub warehouse, which we can do as an inner class. And we'll tell it the level of the stock, for example, that we want to return. In actual fact, just return that product when asked. Okay. So we'll create that as a nested type that implements the warehouse interface. And its job is to fetch the product when asked. Okay, so it's going to pretend to do that rather than actually connecting to the warehouse system. Okay, so this needs to talk to the warehouse. Okay, so let's update our constructor to also take a warehouse. And finally, we need to know what is the restock level of that product. Now, we don't know yet how we're going to calculate that. We've figured it out at a lower level. We've actually got a little example there. But we're not going to think about that yet. We just need a number. So we're going to fake that until we make it as well. So if we go back to our original test, we said the restock level was 24. So we need an interface that provides that number, that restock level. So let's, again, if we take a quick look at our sequence diagram, we called it restock level.calculate. That's what it's going to look like. And this is going to be an interface because we're faking it until we make it. Okay, and again we're going to stub the restock level. Anonymous inner class is Microsoft, and we're going to tell it what level we want it to return, which in this case is 24. So again, taken directly from the spreadsheet. Oops, did not mean to do that. Let's undo that. And let's create it as an inner class, or as they call it, a nested type. And we'll call that the level for now. Okay. Okay. And again, as with the alert and with the warehouse, we need to provide that in the constructor. Where am I actually declaring restock level? That might explain a lot. Okay, and now let's update the constructor. Okay, so that's the complete test. So when I run this test, it's going to fail because we're not actually sending that message. We're not talking to the alert at all. So let's just make sure. When we run our tests, that this test fails. See the test fail? Couldn't find the type or namespace mock. I have a feeling I know why. That's why. It's kind of interesting that it was Ryder thought that it was fine, but NuGet not so much. Okay, let's try again. This is why it's important to run your test before you commit. Okay, so it's running our new test, and let's just check to see why it's failing. Yeah, no invocations were performed, so the method's not being called. That's our failing test. Okay, so I'm just going to do the simplest thing possible to make this test pass. So if we go into our, well, it's going to be in our stock monitor here. Okay, so let's assign that to a read-only field. And then we don't need to check the stock or anything yet. We just, in this particular scenario, we just need to send the alert. So again, let's copy and paste exactly what did we agree we were going to send. So try not to interpret, but this time the product ID can change. Okay, let's rerun our tests. Okay, our tests are passing now. I think because I'm going to do some refactoring now, and I get into the habit before you start noodling and experimenting with refactoring the code, just make sure you've got an easy way back. So let's make sure we've got an easy way back. How to test for stock monitor when restock alert is sent. Okay, I'm not going to push that yet. What I'm going to do is start doing these refactorings. So I want to move all of these into I'm trying. Of course, it's Rider, so it has completely different shortcuts. What was it again? Move, Control R. Right. I'm doing a .NET training course tomorrow. Move to another file. That'll be a good start. So let's call that alert.cs. Okay, and rerun our tests. Okay, tests are passing, that's good. Let's keep going. So before I move stock monitor, let's move product. Control-O. So yes, it would be nice to have the option to do this when you're actually creating the new class. And test. Okay, and what else we got here? Our restock level. I suppose that if it's .NET, that should be I restock level, shouldn't it? And our warehouse. Should have run the tests there. Okay. Okay, and finally, stock monitor itself. The only thing that's real, apart from product, I should say. Okay, and I'm just going to, just so that I'm aligned with the, I am just going to rename these to conform to C# naming conventions. Is that actually renaming? No, it's not, is it? Oh, right. Too used to Java now. Okay. What are you suggesting there? Oh, no. That's not an interface. And finally, let's try renaming it here and see if that does a better job. Yeah, okay, that's more like it. We live and learn. Okay. And that means that I need to change that back to stock monitor. Okay, and it's warehouse that needs renaming. Warehouse. Okay, and the next refactoring I'm going to attempt is a little risky, more likely to break it, so I think at that point I'm going to commit again. So there's an easy way back. Moved source classes into separate files and renamed interfaces. Okay, so I know what I did. Right. Okay, so what I'm going to try and attempt to do now, first of all, let's just make sure that we have references. Nope. So let's add a reference to the core logic, the DLR. And what I'm going to attempt to do is move all of these except for the tests into that folder there, to Guitar Shack. Okay. Let's see if that worked. Okay, test still passing, good. Let's fix these namespaces. Okay, and I'll do them all. So let's just double check. Alert. Yep, we need to do that one as well. So alert, restock level, no warehouse, they're all in the and just going to delete that auto-generated class. Clean up a little. Okay. Okay. And now it's time to think about some continuous integration. So let's merge this code with our main branch. Let's do a push. So, Freudian slip there. Okay, moved source files into guitar shop project. Okay. Git push. So, keeping one eye on the build, let's go back and bring up our build status page. Okay, so it's going to go through the same process that it always goes through. It's going to build it, test it, and if that works, it's going to deploy it to Azure. So this is what I typically do before I code. You're not just thinking about the problem, and it would be nice if more developers thought more about the problem they're trying to solve, but you're also thinking about the design, and that includes the logical design, the high-level design, in terms of roles, responsibilities, and collaborations, and also the technical design, the technical architecture, so that you've got enough of an architecture to get you started. You then need to think about how is this thing going to get built and deployed? How is it going to get out there to the customers? And you need to get that delivery pipeline up and running, basically, whether you're going to be doing continuous deployment or not, whether you're deploying directly into production or into some kind of testing or staging environment. These things do need to be in place before you code. Anyway, that's enough for this week. That's quite a long one, isn't it? So that's what I do before I code. There'll be more coming soon where we'll be talking about what we do after we code. We'll be talking in particular about this practice called continuous architecture. So until then, stay safe, and I'll see you soon.